add-on. This is the third video of complex number. So in the third video of a complex number, we will discuss first what is the function of a complex number. Second topic of the day, or you can say of a video, is what is analytic function. What is analytic function? Third topic of the day is conditions of analytic function. That the function need to be analytic, what condition the function should follow. So let us begin with the very first topic of the day, which is function of a complex number. Function of complex number. So what do you mean by function? Let a function of a complex number or a complex variable is a function which whose range and domain I think I make the mistake. Let me clear it. First erase it. Again, sorry for the mistake. Domain, range and domain both are complex number, or both is of complex variable. So what I want to say is that the function of a complex number is a function whose range and domain both are of complex plane, or you can say complex number. That is, they lie in complex plane. Example of a complex function: let fz is equals to z square plus 1. Here z is equals to, again write fz is equals to z square plus 1. So z is equals to x plus iota y, which is complex number. So writing the value of z in a function x plus iota y square plus 1 is equals to fz. So it becomes x plus 1 plus iota, that is u plus v. Sorry, I have written the square of z, but it is not a square, it is actually a single order. So you can find that fz becomes u plus iota v, where u is a real part of a function and v is imaginary part of a function, part of a function. So this is of a form complex number. So fz is also a form of complex number. Moving to the next, let us discuss a note. The note is that you cannot pose fz and z on a same plane. Instead, you can make a point of fz and z in two different graphs, not on a single graph. Why? Because they cannot lie because of their different form. The z is different from the fz form, and it basically is like a domain. Since similar way, a domain and range cannot be on a same plane. Similarly, z and fz cannot be on a same plane. It is the two different planes, which is, for example, 2 points here mentioned fz1, fz2, which corresponds to the z1 and z2 in z plane. So there are two planes on which we have got they can never lie on a same plane. They always lie on two different planes. Similarly to this, that of range and domain, we can say that in real functions. So the next thing which we gonna discuss is, I hope the previous things are clear to us up till now. The next thing which we gonna discuss is analytic function. So analytic function, what is analytic function? A function is said to be analytic if these three conditions are satisfied. There are three conditions which are need to be satisfied to make it a analytic. The first condition, it is, first, fz should be singular or single valued function. For function to be analytic, fz should be single valued. And second condition, fz must be continuous, or it has a unique derivative, you can say. Fz must be continuous. Third thing, CR equations should be followed, or should satisfy CR equation, that is Cauchy-Riemann equation. CR equation. So CR equations, what are CR equations? Let us see what are CR equation. Suppose du by because of CR equation, du by dx is equals to iota. No, sorry, not iota. Just du by dx is equal to dv by dy. This is a CR equation where fz is equal to u and iota v, and u is the real part and v is the imaginary part. So function need to be analytic follows the third condition, which is CR equation, which means that it should be follow these two conditions. First, du by dx is equal to dv by dy. Next is du by dy is equal to minus of dv by dx. These are collectively known as CR equations, and this is a Cartesian, or you can say the rectangular form of CR equations. U, what is U? Real part of a function, and V is imaginary part. Imaginary part. So now we will discuss standard functions. What are standard functions? Standard function are those functions which are single valued and has unique derivative, or you can say which follows or which satisfy first two conditions, which is a function need to be analytic. That is, first the function is single valued, second it is has continuous, or you can say have a unique derivative. So standard functions first example is polynomial function. Polynomial function example x square plus 1. Second standard function is rational function where denominator is not equal to 0. Where denominator is not equal to 0. Example x plus y square plus x square. The third thing which we're gonna discuss a standard function is sine or cosine function, or you can say a trigonometric function, which is standard is sine or cosine. Example sine cube x or cos 5x. So these are the examples of a standard function which follows first and second rule, which is need to be a function to be analytic. Fourth standard function you can say is exponential function. Exponential function which are e raised to power 2x, or you can say e raised to power y. So these are the standard functions. Now let us find the steps to check whether a function is analytic or not, or you can say the steps to check analyticity of a function. Analyticity of function. So there are two cases. Case 1, case 2. Case 1. Case 1 is then a function fz belongs to standard function, and fz, second case, fz does not belong to standard function. So there are two cases: first where fz belongs to standard function, and second where fz does not belong to a standard function. Standard function is what, which we have discussed earlier. Now if a function is said to be a standard, then only we need to check the third condition, which is we need to check only CR equations. Second, if function is not standard function, check all three conditions to check the analyticity of a function. Then we need to check all the three conditions, that is the fz should be single valued, continuous, and CR equation should be followed. Now CR equation, what is CR means? It's Cauchy-Riemann equation in polar form, that is in form of angle, which we have discussed is in form of rectangle and Cartesian product. Now what we are doing is in polar form. So here what is f? U plus iota v, where u and v are the function of r theta, not xy, r and theta, which are polar coordinates. In previous video we have discussed the polar representation of complex number. I will give the link in I button, you can check it out. So now here du by dr becomes equal to 1 by r dv upon d theta. So this is the first CR equation which needs to be satisfied. Du by dr is equals to 1 by r dv by d theta. Second equation, dv by dr is equals to minus 1 by r du by d theta. So these are the two CR equations which need to be checked for a function to be analytic in polar form. Polar form, or these are known as polar function, or you can say the polar form of CR equation. Now let us recap what we have done till now. First thing, a function. What is a function? Function fz is said to be in where a domain and range is in complex variable. Second, function and z cannot, z is here complex number, cannot lie in same plane. They both are on different plane. Third thing what we have done is analytic function. A function is said to be analytic when a function is said to be analytic. First, it is single valued. It should be a single valued. Second, what is second part? It should be a continuous function. or have a unique derivative at the point. Third, CR equations should be followed. That is, CR equations should be followed. Fourth thing which we discuss is CR equation in polar form and Cartesian form, which is equal to du by dx into dv by dy, or dv by dy is equal to minus du by dy. So these are the CR equations. So this is all about the part 3 complex number. We will continue it in part 4. So I hope you like this. Thank you so much. Keep watching. Thank you.